Hello everyone. Once again, welcome to PM Networking. Hope you all are doing great. Guys, today I am going to create one more playlist on my YouTube channel, and name of this playlist is IPv6. In this video, we are going to discuss basic things about IPv6 address, like how IPv6 address look like, how to configure it. We will discuss packet flow as well. We will discuss auto config IPv6 as well, types of IPv6 as well. But in upcoming days, we will discuss the routing protocols like static routing, dynamic routing, EIGRP, OSPF, all routing protocol with IPv6 implementation. Done. So here lots of the people were requesting me to make one playlist for IPv6. Please make one video on IPv6. So we are not going to discuss only IPv6, but we are going to discuss everything about IPv6 day by day in this playlist. Okay guys, so this one is day one, and without wasting our time, let's begin. First of all, let me compare IPv6 address with IPv4 address. If I will talk about IP version 4, so how long IP version 4 address is? It is an 32 bits address. Yes or no? It is an 32 bits address, and we represent IPv4 address in decimal, right? It is 32 bits address, that means 32 times x. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25 26 27 28 29 30 31 32. This is 32 bits address, and as you know, this x can be your 0, x can be your 0, or x can be 1, right? In binary we have only two values, 0 and 1, and we divide IPv4 address into 8 field, into 4 field, and each field carry how many bits? 8 bits. Each field carry how many bits? So 1 2 3 4 5 6 7 8. This is my single first field. Let me count again. 2 4 6 8. It's 9, so let me reduce 1. Okay, this is my first field. After that, again 8 bit. 1 2 3 4 5 6 7 8. Again 8 bit. 1 2 3 4 5 6 7 8. And again 8 bit. 1 2 3 4 5 6 7 8. So we have one more x. Okay, and we separate each field with dot. As you know, we separate each field in IPv4 address with dot. So there is one dot, dot, and dot. So that's why we say my IPv4 address can be 10.10.10.10. My IP address can be 10.10.10.10. This is one IPv4 address, and this one is a valid IPv4 address. Yes or no? But if I will talk about the IPv6 address, guys, so total length of IPv6 address is 128 bits. 128 bits. And as I told you that we represent IPv4 address in decimal, so we represent IPv6 address in hexadecimal. So represented in hexadecimal. And as you know, in hexadecimal we have 16 character. Hexadecimal, in hexadecimal we have 16 character from 0 to f. 0 to f. 0 means, let's say, let me discuss IPv6 address in detail, guys, because we are going to understand lots of things about IPv6 address later. So if I will talk about the hexadecimal character, so if value in hexadecimal is 0, that means binary is 0 0 0 0 0. If binary is 0 0 0 1, that means my hexadecimal character is nothing but 2 1. If my binary is 0 0 1 0, then my hexadecimal character is nothing but 2. If my binary value is 0 0 1 1, then hexadecimal character is nothing but 3. Let me correct it. Yes, if my binary is 0 1 0 0, that means my hexadecimal character is nothing but 4. If binary is 0 1 0 1, then my hexadecimal character is 5. If binary is 0 1 1 1, then my hexadecimal character is 6. 4 plus 2, not this one directly. Let me, yes, it is what? 4 plus 2, 6 plus 1, it is 7. Yes or no? Okay, let me correct it. 4 5 and 6 will be 0 1 4. After that 1 0. This one is 6 in hexadecimal. 6. If binary is 0 1 1 1, then it is 7 in hexadecimal. 7 in hexadecimal. If my binary is 1 0 0 0, then hexadecimal character is what? Hexadecimal character is 8. If my binary is 1 0 0 1, then my hexadecimal character is 9. If binary is 1 0 1 0, then my hexadecimal character is 10. Or it's not 10 in hexadecimal, as you know, we don't have 10, it's A. Yes or no? If my value is 1 0 1 1, that means my hexadecimal character is B. If binary is 1 1 0 0, then my hexadecimal character is C. If binary is 1 1 0 1, that means my hexadecimal character is D. If binary is 1 1 1 0, then my hexadecimal character is nothing but E. And if binary is all 1, then my hexadecimal character is F. This is first thing about IPv6 address, that we represent IPv6 address into hexadecimal. So, and you know, in hexadecimal we have total 16 characters, 0 to F. 0 to F. So tell me, if we have an address whose size is 128 bits, guys, and represented in hexadecimal, then how many character can be there? Then how many character can be there? Character, total number of character in IPv6 address will be 128 divided by divided by 16. Yes or no? Divided by not 16, it will be divided by 4, because each hexadecimal character carry 4 bits. So one hexadecimal character will carry 4 bits, means 0 is carry 4 bit, 1 is carry 4 bit, F is carry 4 bits. Yes or no? So if I will divide 128 by 4, what value you will get? We will get 32. That means there are 32 character. So if there are 32 character of hexadecimal, That means total size of IPv6 address is 128 bits, because 32 multiplied by 4, each bits carry, as I told you, that each character carry 4 bits. Yes or no? So there will be 32 character in IPv6 address. Done. This is the first thing about IPv6 address. And interviewer can ask you this question also, that why we have only 32 bits, 32 character in IPv6 address. So reason is very clear, because we represent IPv6 address into hexadecimal, and to represent one hexadecimal character we need 4 bits. So total number of character in IPv6 will be 32. Now let's say I have one IPv6 address, 30 times x, 3, 4, 5, 6, 7, 8, 9, 10, 11, 4, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. This is a IPv6 address. This is a IPv6 address. Like we divide IPv4 address into 4 part, we divide IPv6 address into 8 part. So if you will divide 32 character into 8 part, tell me each field will carry how many character? 32 divided by 8, right? That means each field will carry how many character? Each field will carry 4 character. Yes or no? So here 1, 2, 3, 4. This is one field. 1, 2, 3, 4. This is second field. 1, 2, 3, 4. This one is third field. 1, 2, 3, 4. This one is fourth field. 1, 2, 3, 4. Fifth, sixth, 7 and 8. Done. So this is my IPv6 address, and these all x is nothing but your hexadecimal character. X can be 0 to F. X can be 0 to F. Done. And like in IPv4 we separate each field with dot, in IPv6 we separate all field with each field with colon. So here we have one colon. Here also we have one colon. Here also I have one colon. Here also I have one colon. Here also I have one colon. Means we separate each field with colon. And now this one is your correct IPv6 address. This is your correct IPv6 address. This one is a valid IPv6 address. So how many total characters are there? 32. How many fields are there? 8. And each field carry how many characters? 4. And total number of bits in each field is 16. Because as you know, these are hexadecimal character, and to represent one hexadecimal character we need 4 bits. Yes. So each field carry how many bits information? Each field carry 16 bits information, and each field have 4 character. So just let me show you one IPv6 address, guys, like 1A or 1, 2, 3, 4 colon ABC 1 colon 5, 6 AB is B colon 2, 5, 4, 2, 3 colon, how many field we have? 1, 2, 3, 4, and 1, 2, 3, 4 colon 4, 5, 3, 2, 1 colon 1, 2 AB colon BC D1, like this. Anything, I am writing random number 1, 2, 3, 4, 5, 6, 7, 8. Now you can see this is a valid IPv6 address, right? Like this we represent IPv6 address. Okay, now hope it clear till here. If everything is clear to you, then we are going to discuss types of IPv6 address. So till now we have discussed IPv6 address is 128 bits address. We have total 32 character, and we represent IPv6 address in hexadecimal, and we separate each field with colon, and there are 8 fields in IPv6 address. Right? We have discussed only these things till now. Now guys, understand the simplification of IPv6 address. Here I am going to write one correct IPv6 address, that is, let's say 2001 colon db8 0, or here 0 colon 0001 colon 0012 colon 000 colon 000 colon, how many field we have? 1 2 3 4 5 6. Last one is, let's say 0012 or 34. This is my IPv6 address. First simplification rule is we can ignore the leading 0, the left side 0. Here you can see these are 3 left side 0. Here also you can see left side 30, left side 30. Here also we have 2 left side 0. These are leading 0. So we can ignore the leading 0. We can ignore the leading 0. So let me show you how we can ignore. 2001 colon, and see here we have one leading 0, so we can ignore it. Directly we can write db8. After that colon, again we can ignore 3 leading 0 are there, 3 consecutive leading 0, so we can ignore them. 0, we can say directly 1. After that here again we have 2 leading 0, so we can say 12. After that we have 4 0, all 0, so we can put simple single 0 over here, then colon. After that again you can see we have all 0, so we can say 0, single 0, and again here we have 2 leading 0, so we can ignore that and say 24. There is no any difference between this address and this address. Both addresses guys same. Done. Now the second simplification is we can replace consecutive field 0 with dual colon. So here you can see we have 2 consecutive field with 0. Here also we have 0, and here also we have 0. So we can replace it with dual colon. See, like how 2 consecutive 0 field can be replaced with dual colon. But there should be only one dual colon in entire IPv6 address. Okay, so 2001 colon db8 colon 1 colon 12 and double colon 34. There is no any difference between these 3 address. All are same IP address. All are same IPv6 address. And if I have an address like this, 2001 db8, that means here we have 0 db8. Yes or no? 0 db8. Then colon 0 colon 0 colon 0 1 2 0 colon 1 2. How many field we have? 1 2 3 4 5 6 and 0 0 and let's say 1 2 3 4. This is my IPv6 address. We have already ignored the leading 0 here, because you can see here we have 1 0. The complete IP address means here we have 4 times 0. Here we have 4 times 0. Right? Here 12 have also 2 0, 2 leading 0, like this. Here also we have 4 times 0, and here also we have 4 times 0. This is the full IPv6 address. After simplification, you can first reduce the leading 0, right? Here also, here also, here also, and here also, right? But this is not complete simplify address. So you can see here I have consecutive 3 0, and here I have consecutive 2 0. So where you have consecutive more 0, that will be replaced by dual colon, and there can be not more than one dual colon, guys, in the entire IPv6 address. So here we cannot replace these consecutive 0 with dual colon, because in IPv6 address there can be only single dual colon. So 2001 colon db 8 dual colon 12 colon 0 colon 0 colon 123. We cannot simplify more than this. Done. So if I am writing one IP address over here, let's say 192.168 dot not dot colon 192 colon 168 colon 10 double colon 1. That means, it means what? My complete IP address is 0192 colon 0. Here we have 168. This one is, let's say, 168. So 168. After that colon 0010, and then how many field we have over here between these dual colon? See, 1 2 3 4 total we have are, I am able to see there are 4 fields. That means between dual colon there are 4 fields. So 0000 colon 0000 colon 0000 colon 0000 colon 0001. This is the IP address, unsimplified IP address, but there is no any difference between this address and this address. Both are same, right? This one is simplified IP address, IPv6 address. So if I am saying 12 double colon 1, that means my IP address, this is a simplified IP address, IPv6 address. The complete IPv6 address will be what? 12 colon 0 colon 0 colon 0 colon 0 colon 0 colon 0 2 4 6, and after that colon 1. How many field we have? 2 4 6 8. Yes, this is the complete IPv6 address, and this is simplified IPv6 address. If you will unsimplify again, so it will be 0012 colon 000, like this. You can write the full IPv6 address. Okay guys, now hope it clear to you that how we can simplify the IPv6 address, right? We have two rules. First rule is we can ignore the leading 0. After that, if we have consecutive 0 field, then we can replace that with single dual colon, but we cannot put more than one dual colon in IPv6 address, because in IPv6 address, whenever we have dual colon, so through dual colon we can identify that how many fields are there between dual colon. So, but if we have more than one dual colon, then we cannot identify that how many 0 is over here and how many. Let's say I am writing one IP address just to make you understand again. Let's say I am writing one IP 12 double colon 1 double colon 1. So you cannot here write the full IPv6 address, because you don't know how many fields are there here and how many fields are here. So that's the reason why we can put only one dual colon, right, in the entire IPv6 address. Now hope till here everything is okay. If you have any doubt, guys, you can let me know in the comment. Now I am moving further. Now see one more thing over here. As you know, total size of IPv6 address is 64 plus 64, 128 bits. Guys, we don't have subnet mask in IPv6 address. We have prefix length, right? So first 64 is your network portion and last 64 is your host portion. If I will talk, this one is your host portion, network portion. Network, we can say bits, and last 64 is my host bit. Host bits. Okay, this is first 64 bits and this one is last 64 bits. 64 bits. Done. Now out of 64 bits of network portion, we have divided this 64 bits into some part, into 4 part. 1, 2, 3 and 4. Guys, in first 64 bits, 3 bits are reserved for INA. 3 bits are reserved for INA. For INA. As you know, INA is an organization who is managing these things, right? 3 bits is reserved for INA, and the first 3 bits will be always 2 or 3. 2 or 3 means value which is reserved over here is 2 means what, guys? See, we have 4 bits in first field. First field we have 4 field. See, out of these 4 bits, 3 bits is reserved for INA. That will be always same, and that bit is 0, 0, 1, right? And last bit over here is free. Last bit over here is free. So this value can be 0, this value can be 1. 0, 0, 1, and this value can be 1. If this value is 0, then what value you will get over here? 2. If this value is 1, then what value you will get over here? 3. So first value will be always 2 or 3, but nowadays we are using 2. If you will check my IP address, also you will see first value will be what? 2 in IPv6 address. Let me show you. Let me open my browser. Let me open any browser, and here if I am say what is my IP address. See, my IP address is starting with 2. Yes or no? So as I told you that this bit is reserved. This bit will be always what? 2 or 3. But now we are using 2 only. So this bit will be always 2. So let's say I have one IP address 2.0.0.1. Okay. So this is how many bits? 16 bits. Out of these 16 bits, as I told you, 3 bits is reserved for INA, right? After that, this I was talking about this 16 bits. 16 bits plus 16 bits over here, 16 bits over here, and 16 bits over here. Total 64 bits. Done. Okay. Now this 60 bits is reserved for RIR. RIR stands for what? Regional Internet Registry. This is reserved for what? For RIR. So let's say I have one IP address. Let's say IP address is 1.0.1:1234. So here these bits I cannot change these bits. These are reserved bit. And here let's say I have one more field reserved for my ISP, for tier 1 ISP. Let's say for Geo, this field is reserved, third field, that is, let's say 1010. Done. Now how many bits we have free? 16 bit. Yes or no? So 16 bits I can use any number over here. Let's say I'm using 000A, right, slash 64. This is my network portion. So that's why, first 48 bits is reserved. That's why sometimes we are saying 48 bits are root prefix. So we cannot change these prefix, right? And these bits are for subnetting, right? This is my first network. If I want to create one more network over here, so in my second network, see, 48 bit will be same, 001 colon 1234 colon 1010. After that 000B. Let's say this is my second network, right? And last 64 are host portion, right? Here I can write anything. This is my host portion. Here let's say my value is dual colon 1. Here my value is dual colon 2. Dual colon 2 means you are getting me what I am saying. In between dual colon, how many fields are there? So there are all 0. This is my network 1, this is my network 2, this is my another network. Let's say if I want to create the multiple network, I can change value over here only. So we have 16 bits for the subnetting, right? We can change these 16 bits, here 16 bits, okay? So first 48 bits is reserved. Let's say I have this is a company whose name is PM Networking and XYZ, right? Whose network is, first network is this one, whose second network is this one, right? Like this, they can create how many network? 2 to the power 16 network. They can create 2 to the power 16 network because they have 16 bits for the subnetting, right? And in the host portion, you can see I have 1, 0, 0, 0, 0, all 0 and 1, right? So this is how like we are using IPv6 address. Here in my scenario, if you can see, this is my IP address. So here also, this one, okay, first bits is reserved for INA. After that, 16 bits is reserved for RIR, and then for ISP, and here we can change it. Here we can change it. Suppose I want to create the network, so here I can change, let's say 34, 35, 36, 37, 38. So we have 16 bits for the subnetting. Done. Now hope this is also clear to you. If you have any doubt, you can let me know in the comment section. Now let me move further. Now guys, let's understand types of address. Types of IPv6 address. So if I will talk about the type of IPv6 address, so we have 3 types of IPv6 address. First one is unicast. Second one is multicast. And third one is anycast. We don't have any term like broadcast in IPv6 address. Okay. Unicast is 1 to 1, as you know. Anycast is multicast is 1 to many, and anycast is 1 to nearest. 1 to nearest. Okay. Any unicast is 1 to, let me show you. Here I have one file with IPv6 address type. So you can see unicast, multicast, and anycast. Unicast means a unicast address uniquely identify an interface on an IPv6 device. So on an IPv6 device, uniquely we can identify a interface with unicast address. A packet sent to a unicast address is received by the interface that is assigned to that IP address. Definitely yes. So if you are sending a packet to a unicast address, so only that interface will receive that traffic where you are running that IP address. Similar like IPv4 source, IPv6 address must be unicast address. Yes, source will be a unicast every time. Source can be not multicast or anycast in IPv6 address also, and in IPv4 address also. Okay. In IPv4 address, sometime we have source 0.0.0. Yes or no? Like what? When guys? In the case of DHCP, In the case of ARP, in the ARP request message, destination is 0.0.0, but in the Ethernet header destination is broadcast. I'm talking about the source. So in DHCP discover message, source was 0.0.0. Okay, now there are three types of unicast address. This is very important. Okay, this one is very important of IPv6 topic. Okay, so we have three types of unicast address. Okay, multicast and anycast is, we will discuss it about later. Understand unicast first. There are three types of unicast address. First one is global unicast. Guys, global unicast address is, see, a routable address on IPv6 internet. That means this address is like your public IP address. Remember the public IP address of IPv6 at IPv4 address, which is routable on internet. Like that, global unicast address is routable on internet, and it is an unicast address, similar like public IP address of IPv4 address, starting with 200/3. As I told you that 3 bits is reserved, right, for INA. So it will always start from 2, and here value can be anything, right? The first 3 bits is reserved, assigned for by INA, right? That will be 001, and fourth bit can be 0 and it can be 1. So in some book you will see the global unicast address will start from 200/3/3, but it can be a start from 3 also, because only 3 bits is reserved. Done. After that, unique local. Unique local is similar like your private IP address. This IP address is not routable on internet. Like, you know, IPv4 address, remember 192.168.10.0. You are using this IP address inside your private network, and if you want to make communication possible between private and public, you are using NAT, right? So because your private IP address are not routable on internet, like that, unicast local IP address is not routable on internet, similar to your private IP address in IPv4 address, not intended to be routable in the IPv6 internet. It can be used similarly as global unicast address, but are for private use only. Okay, should not be routable in the global internet, and this address will always start from FC00:7, right? Here we have 7 bits reserved for unicast, unique local. For unique local we have 7 bits reserved. It will be always start from FC, right? Or it can be a start from FD also, starting with FC or FD in the first 2 number. Okay, so that is your unique local address. So you can write down somewhere this point, right? Global unicast and unique local cast, there is some range, right? After that, we have third type of unicast address, that is link local address, used only to communicate with device on the same link, right? So we will discuss about link local later, guys, much about link local address. It is auto config address. Whenever you will configure IPv6 address on the interface of any device, automatically that device will create one link local address to communicate with same link device. Let's say I have one router over here and one router over here. I have configured IPv6 address over here, IPv6 address. So it will create one link local address to communicate with same link connected device, to communicate with router number 2. On the same link, which device is connected? Router 2. So it will communicate with router 2 through link local address. And link local address of router 2 will become gateway for router 1. And link local address of router 1 will become gateway for router 2. Done. So it is auto config address. We will understand that how router is automatically calculate or create this IP address. It is an default IPv6 address on every IPv6 enabled interface, not routable on internet. And this IP address always start from this address, right? FE80. Always keep in mind here we have 10 bits reserved for the link local. It will be always start from FE80. Router do not forward packet with link local address. Definitely whenever router need to forward a traffic to any other devices not on the same link, it will not use link local address to forward traffic. After that we have multicasting. So multicasting, as you know, multicasting is similar like class D address in IPv4 address. IPv6 multicast improve network efficiency by allowing a host to transmit a datagram to a targeted group of devices. Okay, multicast. Now let me tell you anycast. So an IPv6 anycast address is an address that is assigned to more than one interface, right? Anycast address can be assigned to a multiple devices. Like let's say we have some server in my network, 10 server, right? We have different server in different city. Okay, so we can assign same IP, same anycast IP address on all server, and typically the address belongs to a different node. A packet that is sent to an anycast address is routed to the nearest interface that has the IP address, right? So if let's say I have 10 server in different city and I have configured the same anycast address on all server, and if you will request for the server, so it will find the nearest server, right? Anycast means it is nearest one to nearest IP address. Okay, so like on the Google server, let's say there is one Google server in US and one server in India. Both are using anycast address. If you will forward traffic to Google, your router will forward traffic to India server if you are forwarding it from India. Done. So this is how anycast is works. Now guys, method to configure IPv6 address on the machine. How many method we have? So first method is like you tell me how many method we have to configure IPv4 address. Two options we have. Either we can define the IPv4 address to the interface of machine manually, or we can configure IP address through DHCP. So we have two options generally, right? In the IPv6 also, first option is manually. Manually, you can define the complete IPv6 address to the interface of IPv6 to IPv6 interface. After that, second way is stateless DHCP. Stateless DHCP version 6. And the third one is stateless auto config. We call it SLAAC, SLAAC, stateless address auto config, right? Means router can automatically generate IPv6 address. Auto config. Done. Auto config, or you can say auto configuration. Now let me show you the configuration part. Here you can see I have two router. I am going to start the node. First of all, we are going to discuss the link local address. Let me configure one IPv6 address over here. On, let's say on F0/0, I am going to configure one IPv6 address. You can define link local address also manually, or if you will not define the manually, machine will generate automatically. Let me show you. Wait. Yeah. Config T, hostname R1. Done. Interface F0/0, say IPv6 address. Here I am going to say 2001 colon, or directly I can say 12 double colon 1. Let's say I am defining this IP address. After that you need to define the prefix length as well, /64. Okay. We don't have subnet mask in IPv6 address, only prefix length we have. Now, so IPv6 interface brief. See, this is the IPv6 address which I have configured, and this IP address is link local address. This one is link local address. This interface is down. Let me run no shut command as well. Interface F0/0 no shutdown. So IPv6 interface brief. See, this interface have one link local address, and this interface have one global unique address, that is 12 double colon 1. This is global unique address, and this one is link local address. Now I am going to copy link local address from here, and let me paste this address in Paint. Here I am going to paste this IP address. See, this machine have created this link local address. How this machine have created this link local address? It is also very important for you to understand. Getting my point? Okay. Now, machines create their link local address with the help of MAC address. What I am going to do, I am going to copy MAC address of this interface. So interface F0/0 and say include BICE. See, this one is the MAC address of this interface. Okay, let me paste it over here. MAC address. Guys, first step is, as you know, first step is it is going to divide MAC address into two parts. As you know, MAC address is a combination of two things, OUI and vendor assign, right? First, total size of MAC address is 48 bits. First 24 bits is OUI, organizational unique identifier, and last 24 bits is vendor assign. So it is going to divide it. This is first 28 and last 28. In between OUI and vendor assign, it is going to put F. Let me change the color. It is going to add F E. These 16 bits. It is going to put 16 bit, that is FFFE. Okay. After that, here it is dot. In MAC address you are able to see the dot, but in IPv6 it separate each field with colon, so it is going to use colon over here as well, and colon over here as well, like this. Now how many bits it is? 48 plus 16 bits. Now still 16 bits is required, yes or no, to complete one IPv6 address? Yes or no? To complete IPv6 address, still more bit is required. See how many fields are there? 1, 2, 3, 4. Only 4 fields are there, right? That means 4 more field is required. 16 multiplied by 4. So it is going to use the dual colon. Here in the starting, first of all, it will put FE, as I told you that your link local address will always start from FE80, and here it is going to use double colon. After that, in the MAC address, it is going to convert the 7th bit. So this is your MAC address, right? See, 7th bit is here. This is in the A. 7th bit is there in the A, right? So it is going to convert 7 bits, means if 7th bit is 1, then it will convert it to 0. If 7th bit is 0, that means it will convert it to 1. So 7th bit of my MAC address is here. See, MAC address is this one. Here in the A, 7th bit is there. So it is going to convert A into binary. Where is bent? Sorry. Okay. Binary of A will be what? 10, 10. 7th bit is which one? First C is 4th bit. This one is 5th bit. C means what? 4th bit. 4 bit. 4 bit is required to represent C. First MAC address, first character in MAC address is C. The second character in MAC address is A. So C character carry 4 bit, and A character also carry 4 bits. So I am interested to find the 7th bit. So this one is 5th bit. This one is 6th bit. This one is 7th bit. So 7th bit is what? 1. So it is going to convert it into 0. So if 7th bit will be 0, then value will be 1, 0, 0, 0. And decimal value will be what? Decimal value will be 8. Yes or no? So now my final link local address will be same this one, but it is going to replace this A with 8, the new value. And now you can check your link local address and your IP, sorry, this address and your link local address both are same or not. Yes, both are same. Link local address are simplified, so you can simplify it like this: FE 80 dual colon C 801 colon 6B F colon FE 87 colon 0. This is your final link local address. Let me copy it and let me paste here. This address and this address. You can match both addresses same or not. Yes, both MAC addresses, both link local addresses same. So this is how routers calculate link local address. Okay. After that, I am going to capture this link F0/0 0/0. See, whenever you are configuring IPv6 address on the interface of router, right? Or whenever you are configuring IPv6 address, first of all, tell me, when we are configuring IPv6 address on the interface of router, first of all, router is going to check what? Duplicacy, that the IP address is duplicate or not. In the same way, router is also in IPv6 also, router is going to check the IPv6 address is unique or not. So I am going to capture this link F0/0 of router 1. Okay, this is my capturing. You are not able to see anything. See, now I am going to remove the IP address from the interface, and again I will configure the IPv6 address. Say no, IPv6 address 12 double colon 1. I have removed it and /64. Remove it. Now I am going to configure the same IP address again. So when I will configure IP address, it is going to check the duplicate IP address with the help of neighbor salutation message. Router uses neighbor salutation message. This is a message of ICMP version 6. Okay, so IPv6 address and 12 double colon 1 /64. See, it have sent one neighbor salutation message. Yes, ICMP version 6. Here IP address is, this is link local address. It will send two neighbor salutation message, one for link local and one for global unicast. Yes or no? So this is one neighbor salutation message, and there should be one more neighbor salutation message. That is, here it is. And in this neighbor salutation message, you can see target IP address is 12 double colon 1. So after that, router is sending what? Neighbor advertisement as well. Neighbor advertisement, and target is 12 double colon 1. So see, actually what is happening, flow is, whenever I am configuring IPv6 address over here, 12 double colon 1 /64. It is sending one salutation message, neighbor salutation NS message, right, to find the duplicate IP address. In the same way, link local will also generate one NS message. And if router 2 is using that IP address, then router 2 will send what? NA, neighbor advertisement. But if this router 1 will not receive any advertisement, then router is going to advertise it, neighbor advertisement. It will advertise that now I am using 12 double colon 1. Then it will send NS message as well as NA message. If I will configure IP address on router number 2, same IP address 12 double colon 1, let's say. So it will send what? Neighbor salutation message, and router 1 will give advertisement. Then you will get error, duplicate IP address. That is dead. The process of checking duplicacy is dead. Okay, duplicate address detection, dead. What we called it, to the process of checking duplicate IP address is dead. Here see, I am going to configure the same IP address. Guys, I will complete the entire things of IPv6. Don't worry, I will cover routing protocol as well as static routing, dynamic routing, everything, right? But day by day, so please keep patience. Maybe every day or in a week you will get 4 to 5 video at least. I will try to upload 5 video in a week. F0/0. Here say no set and IPv6 address 12 double colon 1 /64. Done. See the capturing as well before it. Okay, before that let me show you the capturing. Let me close this. Okay, see, on router number 2 I'm going to hit enter over here. It will send neighbor salutation message. See the neighbor salutation message for link local and neighbor salutation message for 12 dual colon 1, and it is getting neighbor advertisement from 12.1 from router number 1, right? This is nothing but that. And on router number 2 also you can see you are getting the error or not. Duplicate address 12 double colon 1 on fast ethernet 0/0, but it will assign the IP address. Do so IPv6 interface brief. See, the IP address of interface is 12:1, but it will give you one error. This error. Done. Now I am going to say no. No. And one more thing, here you are not able to see. See, now these two router are normal router. Right? We have configured IPv6 address, but by default IPv4 unicast routing is enabled on this router, but IPv6 routing is not enabled. So once we will advertise, we will enable the IPv6 routing on router, router will start advertising, router will start sending RA message, router advertisement. So if this client need IP address, this client can get IP address automatically from router number 1. Now on router number 1, what I am going to do, I am going to configure one IPv6 address on LAN interface as well. LAN interface means on F1/0 interface F1/0 NOSUT and IPv6 address, let's say 192.10.10.1/64 dual:1/64. I have configured this IP address over here. So IPv6 interface brief. You can see IPv6 configuration is done. This is link local address and this is global unicast address. Here also on F0/0. But this PC, let me check the PC is getting IP address or not. IP config. See, this PC is not getting IPv6 address. But here on PC, if you will check the method of IPv6 configuration, you can check. You window plus R. Oh. ncpa.cpl, and let me check the method of IPv6 configuration over here. See, obtain IPv6 address automatically, but this client is not getting IP address. Yes or no? Because now router is not sending RA, router advertisement message. Now let me discuss first what is RA. What do you mean by router? RA or router is not sending RA. See, when we will enable IPv6 unicast routing on router, done. This is my topology. Okay. When we will enable IPv6 routing on router number 1, router will send what? RA. In the RA there will be some information, like there will be information about yes, here let's say this is RA of router 1. Router 1 is advertising RA. And why router will advertise it? So that client can get IP address automatically. After that there will be prefix information. There will be prefix information. Prefix, and prefix of this interface is 192.168:10:/64. This is the prefix, right? After that there will be information of prefix length. Prefix length. So prefix length is 64. Getting my point? After that there will be one field, auto address flag. and this field will be 1 on. Okay. So when window machine or this client will receive this array message, it will check first this flag field. Okay, I need to configure the IP address. Okay, it is sending what? It is sending what? Network portion and network length. And this machine, this client will get automatically 64 bits from the link local. That is host part of link local. Host part of link local means 64 last 64 parts of link local is called EUI64. EUI64. Getting my point? So see, like router number 1, I am going to enable IPv6 routing. So say IPv6 unicast routing. Done. And after running this command, see, router has started sending what? Array, router advertisement. Are you able to see? And destination is what? FF02:1. Yes or no? Okay. Multicast address. It is sending again same address. Yes, it is sending same message, router advertisement again and again. So PC can get IP. Okay. So now on PC, if you will check that PC have get IP address or not, you can see. IP config. And see, this machine have IPv6 address. Yes or no? Okay. Now, let me take you on the topology again. Here, on router number 2, I am going to configure the IPv6 address. Now you can see there is no IPv6 address. So IPv6 interface brief. There is no any IPv6 address. Let's say interface F0/0. IPv6 address 12:/64, and I can tell to this router that take last EUI 64 from the link local. So now show IPv6 interface brief. You can see this router have network portion 12::, and this one is what? Last 64 bits of link local. Last 64 bits of link local. Both are same. Or I am going to say this to know. Interface F. EUI64 is last host portion of link local, we can say 0/0. Here if I will change IPv6, let's say FE80:2 and say link local. I have configured this address as link local. What happened? Address FE80:2 and say link local. So I have changed the link local address, so automatically my IP address will also change. So IPv6 interface brief, you can see. Done. Actually it is taking last EUI, last 64 bits from the link local. So it will copy last 64 bits from the link local. Okay. Now I am going to say again no IPv6 address interface F0/0. Say no IPv6 address. So IPv6 interface brief. Now you can see there is no any IPv6 address. I am going to tell to this router that you are IPv6 client. So if this one is IPv6 client, so say IPv6 address interface f0/0 IPv6 address autoconfig. Autoconfig means it is going to take network part from router number 1. Here is capturing. See, router 1 is advertising array. It is sending array. After every 200 second, it is sending array. And here I am going to say, see, neighbor solicitation message just for check, just to check duplicate IP address. So IPv6 interface brief. Router 1 have provide only network portion. It have taken last 64 bits from the link local. This one is EUI64. Done. So router 1 is providing only prefix and prefix length. Only prefix and prefix length. Done. Interface F0/0 IPv6 address 12:1/64 and IP address, and on router number 2 interface F0/0 IPv6 address 12F:2/64. Done. Ping 12F:1. See, it's working. Ping is working fine. It is going to use ICMP version 6. So echo request, you can see ICMP version 6. Now on router number 1, let me show you something. This is my IPv6 server R1. So IPv6 interface fast Ethernet 0/0, let's say. Here you can see it is sending array. Array are sent every 200 second, means after every 200 second it is sending array, and it have joined the multicast group FF. Okay, so that was not FE, sorry, extremely sorry, FF02:1 and FF02:1, right? Multicast address is not FE, FF. FF02:1, FF02:2, and this is the address. Okay guys, so it has joined both multicast group, right? So it can send multicast traffic to client also and to DAD. That means duplicate address detection. The method of checking the duplicate IP address is known as DAD. Okay, hope now it's clear to you. Now that's all for today. If you have learned something from this video, please hit on like button guys. If you have not subscribed this channel, please subscribe this channel. We will meet soon in next video. Till then, stay safe. Bye bye.